Okay, and you need to find I total, the power, and the power factor. So these three um, objectives you need to find. Okay, so how will you find the current? So I total probably you can find by finding out the branch currents I1, I2, and I3. Right. Now, whenever you solve the single phase AC circuit problems, you consider it is similar to your resistive circuit. Only difference is that when you express the resistance in single phase AC circuits, along with resistance, you will consider the reactance. Only that is the difference. Okay, so basically in single phase AC circuit, impedance will come into the picture. Okay, so let us try to consider that Z1 is 10 ohm resistance. Okay, let us say this is Z1, say this is Z2, and say this is Z3. Okay, so Z1, let us say that 10 ohm resistance. So in complex notation, you can write 10 plus J0. Okay, no harm done. 10 plus J0. And Z2, basically we are having RL circuit. So it is R plus JXL, where XL is equal to 2 pi FL. Alright. So 2 into pi into 50 into L. L is 0.1 Henry. So 0.1. So that will give you the XL value. So XL value is 31.4. Okay. So that completes your impedance description. So Z2 is equal to R, which is 20, plus J into XL, 31.4 ohms. That's your Z2. Now Z3. Z3, we have called Z3 as a series RC circuit. So what is it consisting of? Resistance of 15 ohm and a reactance given by this 150 microfarad capacitor. So Z3 you can write it as R minus JXC, okay, which is equal to, we need to find out. Okay, so what is XC? XC is 1 by 2 pi FC, correct? So what is 1 by 2 pi FC? 1 divided by 2 into pi into 50 into C. C is 150 microfarad. Okay. So try finding out XC value. How much you will get? XC is equal to 21.2. Great. So the impedance is 15 minus J 21.23 ohms. Okay. See, the problem is you may be knowing to express the impedances. The problem with single phase AC circuit is that you are not able to get the final answer. That is the worrying factor for me. You may do or you may solve the problem in bits and pieces. That's fine. But you have to get the final answer. That I'm not able to, understand. Why are you not able to, get the final answer? That's the reason I'm spending this one more hour for single phase AC circuit problems. Fine. So Z1 is known, Z2 is known, Z3 is known. Having known Z1, Z2, Z3, you can find out the respective currents, right? Now, the given circuit is a parallel circuit. As you know that in case of parallel circuit, terminal voltage remains the same, right? So a terminal voltage of 230 volt is applied across impedance Z1, impedance Z2 and impedance Z3. So therefore, you can write I1 is equal to V by Z1. So I1 is equal to V. V is 230 divided by Z1. What is Z1? 10 plus J0 or simply 10. So it is basically 23 amperes. 23 amperes. You can also say 23 at an angle 0 degree because it's the resistor current. In case of resistor current, the phase difference between voltage and current is 0 degree. So 23 amperes is your first current. Next you find out I2. How will you find I2? Divide voltage with the respective impedance, that is Z2. So V is 230 divided by Z2. What is Z2? 20 plus J 31.4. Alright. So try finding out the answer. I'll get my calculator. Okay. Alright, I'm not able to find the calculator. So tell me I2. How much do you get I2 as? 6.8. Right. I2 is equal to 6.18 at an angle minus 57.5. Correct?
Yes, sir.
Yeah, amperes. Good. So that's I2. Once you are done with I2, you can find out I3. So I3 is equal to V by Z3. So voltage is 230 and impedance you have already found 15 minus J 21.23 is equal to some magnitude and phase angle. Okay, please calculate. I see that in the book the answer is 8.85 at an angle should get a leading angle 54.7 amperes. Okay, are you getting the same answer? 8.85 at an angle 54.76 degree amperes.
Yes.
Yeah, good. So what you have done so far, you have calculated the individual currents. Okay, I have erased the circuit, but if you look at your circuit diagram, you would see that the total current IT is equal to sum of the branch currents. So total current IT is I1 plus I2 plus I3. Okay, so add up the three currents and tell me how much will you get the main current as. So main current IT is I1, I2, I3, or IT is equal to I1, which is 23, plus I2 6.18 at an angle minus 57.5. Okay, remember, I mean, all these currents you can directly substitute in your calculator. So you must know how to operate the calculator. Don't rely on your friend's answer which he or she is going to share over WhatsApp. Okay, you should physically enter these values and you should try to get these values. Okay. So what do you get I total as? Take your time. That's okay. Take your time. Yeah, let me just check. So she's saying, yeah, 31.4, 31.5. That's fine. And at an angle,
3.7.
0.6. Okay, 3.7. 3.7 degrees. Okay. And so that's your I total. So that is your first part of the problem, finding out the main current. All right. Okay. What was your second part? Second part was to find the power.
Power.
Yeah. So power P is equal to VI cos phi. So V is the RMS value of supply voltage 230 into I, the RMS value of supply current. What is your supply current? Is nothing but the total current. And when you say RMS value, you need to consider the magnitude part of the current. Okay, so it's not the real part of the complex equation, it is the magnitude part of the complex number. So how will you find the magnitude? Either using calculators or by using Pythagoras theorem, right? That is Z is equal to under root x square plus y square. So magnitude of current is 31.5 into cos phi. So cos of, okay, phi. What is phi? Phi is called as the phase angle, and phase angle is nothing but angle between voltage and current. What is that angle? 3.7 degree. So this is your phi. 3.7 degree. So that will give you the power. Okay. So how much you will get power as? 7230? Close to. You must get the power as 7250 watts. Okay. Just check whether you are getting or not. You are getting?
7,225.
Ah, that's fine. 7225 is also fine. So 38 are present, maximum number. All right. Fine. So that's about the power. And finally, you have the power factor. So power factor is nothing but the subset of your power equation. So power factor P is defined as cos of phi. So phi is 3.7. So power factor is cos of 3.7 degree. So you should get very close to unity value. How much you will get the power factor?
99.
Yeah, 0.998. Leading or lagging? Which one? Leading or lagging? Who can tell me whether it is leading or lagging? See, there's so much to learn, correct? So just see the angle, whether it is plus or minus. Plus, right? So leading, correct. Correct. So this phi, if it is plus, if phi is plus, it is lead. If phi is minus, it is lag. Correct. So leading. So that's how we solve the single phase AC circuit problems. All right. Okay. Second problem, let us consider. Okay. Okay. Second problem. Write down. Write down. In the circuit shown below, determine the voltage. Determine the voltage across the points AB. Across the point AB in order to get in order to get 10 amperes as the main current. In order to get 10 amperes as the main current. All right. Also draw the phasor diagram. Okay. So this is the circuit. So you need to find out the voltage across the points AB and also determine the phasor diagram. So this is your point A and this is your point B. So you are supposed to find voltage VAB. Okay, I'll put a question mark here. So this is what you are supposed to find out. 5 ohm, 0.02 Henry, 10 ohm, 400 microfarad, 10 ohm, 0.05 Henry. The main current is given, that is 10 amperes. This current is given 10 amperes. Okay. And frequency of the operation is also given. So the circuit is operating at a 50 hertz cycle. Okay. So this is what they have given. You have impedance Z1 connected in series with a parallel combination of Z2 and Z3. And the circuit current is found to be 10 amperes. Determine the potential across the nodes A and B. So that is what you are supposed to find out. Okay. All right. Try out.
Bye.
Okay. So how will you solve this? So what you can do is you can first mention the impedances. So say suppose the first impedance is Z1 and this is Z2 and this is Z3. Okay, and then you can describe the impedance values. Z1 is equal to 10 plus JXL, where XL is equal to 2 pi FL, and that is equal to 2 pi F, 2 pi into 50 into L 0.05. Okay, that is equal to what you need to calculate. All right. Okay, and similarly, okay, just find out what is it. Similarly, Z2 is, this is 10 plus J. You should tell me what is XL value here. Similarly, Z2 is R plus JXL, and XL of Z2 is 2 pi into 50 into L. L is 0.02 Henry. Okay. So you just tell me what is XL value. So some ohms you will get here. Okay. And likewise, you can find Z3. So Z3 is R minus JXC, and XC is equal to 1 by 2 pi FC. Okay. So XC is equal to 1 by 2 pi into F into C. C is 400 microfarad. 400 into 10 to the power minus 6. So you will get XC value. So just tell me the answers. So keep on doing it. Keep on doing it. And let's discuss about the final answer. So this is 6.28. So this becomes 5 plus J 6.28 ohms. This is 15.7. So this becomes J 15.7 ohms. Okay. And XC becomes so just substitute these values. 7.96. So Z3 is equal to 10 minus J 7.96 ohms. Are you getting this? Did you get the impedance description of the same kind? Can anyone confirm? Okay. So once you have this, what you can do is, for simplicity, I will just replace these values with the impedance. Okay, because I need the circuit diagram, so I'll just replace uh, the L value and C value with the respective complex number. So Z1 is 10 plus J 15.7. Z2 is 5 plus J 6.28, and Z3 is 10 minus J 7.96. Okay. Done. Now, in next step, what you can do is you can find out the drop across Z1. So let us call the drop across Z1 as VZ1. VZ1. Okay. Or you can even use the current divider rule to find the branch currents. Okay. So let's say this is I2 and say this current as I3. Okay, branch current rule let me use. Use branch current rule. So as per branch current rule, current I2 can be written as main current I into impedance of other branch divided by sum of the impedances. So I2 is equal to main current I into impedance of other branch divided by sum of the impedances. Okay. So that is equal to, okay, what is main current I? I is 10 amperes, it is given, into Z3. So against Z3, we have the description of Z, that is 10 minus J 7.96 divided by Z2 plus Z3. So Z2 is 5. So 5 plus J 6.28 plus Z3, Z2 plus Z3, right? So 10 minus, okay, so 10 minus J 7.96. Okay. So simplify this and you can tell me the value of I2. How much you'll get I2 as? Did anyone calculate? Okay. I'm getting I2 as 0.8467 at an angle minus 35.7. So once you know I2, you can find I3. Either you can use current division rule or you can use KCL. Okay. So main current I, okay, because it is vector current, vector number, so I is equal to I2 plus I3. So I3 is I minus I2. So I3 is basically main current, which is 10, minus this 0.8467 at an angle minus 35.7 degree. Now I'm calculating all these currents because I have to draw the vector diagram, right? So for that sake I am calculating. The potential you can directly find out, that is Z equivalent into I gives the potential difference across the combination. But I also need to find out the second part, that is about the current. So calculate I3. This answer you just check once, okay? It's not 0.8, it is 8.46. This is 8.46, okay? And then you can, angle remains the same, then you can find out I2 angle, sorry, I3. Okay, so that's 5.31 at an angle 64.29. Okay. So that is I3. So you have found I2 as well as I3. So that will help you in writing down the vector diagram. Okay. So I2, let me write it here, 8.46 at an angle minus 35.7. And I3, I will get it as 5.31 at an angle 64.29 degree. All right. Now let us find the voltage across VAB. So voltage across VAB is equal to I into ZAB. So what I'm trying to tell you is that if you can find out the equivalent impedance across the points AB, you can call that particular effective impedance as ZAB. So impedance into main current gives VAB. So what is ZAB? So ZAB is basically series combination of impedance Z1 and the effective impedance Z2 parallel with Z3. So 10 plus J 15.7 plus the parallel combination of these two impedances, that is Z2 Z3 divided by Z2 plus Z3. So that is 5 plus J 6.28 into 10 minus j 7.96 divided by z2 plus z3. So 10 plus 5 directly I can write 15 minus j 6.28 sorry plus j 6.28 and minus j 7.96, and that is equal to, I need to find out the answer. So put it in your calculator and try to find out the answers. So ZAB, please check, you will get it as 24.32 at an angle 52.84. 52.84, okay, ohms. So once ZAB is known, you can find out VAB. Therefore, VAB is equal to I into ZAB. Okay, you have already written the formula here. Okay, so I'll write it here. So I is 10 into ZAB, that is 24.32 at an angle 52.84. So VAB is equal to, so you are just multiplying with 10. So 243 you will get as the magnitude, 243.2 at an angle 52.84 degree volts. So your supply voltage is 243.2 at an angle 52.84 degree volts. So that's your, you can say that the supply voltage value. Okay. So that's how you find out VAB. Okay. Now let me write here VAB. VAB is equal to 243.2 at an angle 52.84 degree. Alright. So once you have this, you can draw the vector diagram. Okay. Vector diagram. How will you draw the vector diagram? Over here, what you can do first, project I2 and I3, and then you can draw the I. So what I'm going to do is, I'm just going to draw the reference planes, X plane and the reference Y plane. And with respect to these two planes, let me project current I2 and current I3. So current I2, what did we get? Magnitude of 8.46 and angle of minus 35.7 degree. So angle is negative, so you have to project it in fourth quadrant. All right. So let's project 8.46. So 35 degree approximately. I'm taking. So here I'll take. So I will take this as I2, and this is my angle 35.7. All right. So that's my I2. And then I3, what did I get? I3 as 5.31 at an angle 64.29. So magnitude is less compared to I2. So smaller length you are supposed to choose with an angle of 64.2. This is 45. So probably I'll take this. Okay, so this is my I3 and the angle is 64.29 degrees. Okay, and then let me resolve the vectors. So what I'll do, the same length I'll project here. And this. Okay. So somewhere here, this line will meet. Okay. And this gives me the resultant. Okay. So this resultant is I. And what is I? So I is equal to 10 at an angle 0 degree and flips. So this is my resultant, because as you can clearly observe that I is equal to 10 amperes. There is no angular part. So if there is no angular part, you can say that the resultant current will occupy the x-axis, because along x-axis angle measurement is 0. So that's how you project the current vectors. Okay. Finally, what do you have? You have VAB. Okay. Now, what is the magnitude of VAB? 243.2 volts. And what is the angular part? 52.84 degrees. That means to say, between voltage VAB and between current I, there is an angle separation of 52.84. So accordingly, you have to project your voltage vector. All right. So angle is positive, hence the voltage is found in first quadrant. So how are you going to draw? So you can draw voltage with a different scale, voltage scale. Okay. But make sure that angle separation between VAB and I is 52.84. So let's say this. So I'll call this as VAB, and angle between current I and voltage VAB is 52.84 degree. So this is my vector diagram. Okay, so this is how I solve. So though I had been asked to find out only VAB, but the question also had the information about vector diagram. So in your exam, probably what we can ask you is that, a similar problem of this kind, and we may ask you to choose the appropriate vector diagram. Okay, what is the vector diagram for the problem shown below? That could be one of the question. So